All right, let's take a look at density. It says here on the right, objects that sink in water are more dense than water, and objects that float in water are going to be less dense. You can see in the beaker here, which is mostly water, you can see there's four other components in the beaker. The ones that have a density value less than 1.00 grams per milliliter, which is the density of water. The ones that have a density less than 1.00 grams per milliliter float in the water. So those are cork and ice. And when the density is greater than 1.00, as in the case of aluminum and lead, they sink in the water. So the formula I have down here on the bottom right says density is mass of a substance over volume of that same substance. So we could put the number of grams per milliliter. When we're talking about gases, we use liters, but everything in here is a solid or a liquid. So if you've ever done any density calculations before, you've probably seen the shorthand formula had D is equal to M over V. And of course, you need to have the necessary algebraic skills to solve for M or for V. So if I look at the densities of some common substances, you can see that water is right here, kind of in the middle of the page, 1.00 grams per milliliter at 4 degrees Celsius. You can see that plasma, milk, blood, these are all around the same or very close to the density of water. Whereas when you look at something like iron or aluminum or copper or silver or lead or gold, those metals have densities that are greater than water, and that is why they sink in water. And also, I want to draw your attention to the column on the far right, which is about gases, and it shows that the density for gases is reported as grams per liter instead of grams per milliliter. And the reason we do that is because gases are so light that if we were to measure the density in grams per milliliter, we would end up with smaller numbers, which are just more complicated to work with and can be a little bit more frustrating. So if you're wondering about the conversion factor between milliliters and liters, you have to have this feather in your cap that 1 liter is equal to 1,000 milliliters. So 1,000 milliliters in a liter. So if you wanted to determine the density of an irregular solid, like this zinc rod that's shown here as an example, it says you can determine by dividing the mass of an object by its volume. So it's pretty obvious how to determine the mass of the object. So we just put it on a balance and we weigh it. And you can see here that the mass, oops, where's my pen? The mass is equal to 68.60 grams. So that's there. We use all those significant figures. And then to determine the volume, well, if it was a cube, I mean, then you could just take a ruler and measure the three sides and multiply the length times the width times the height and determine the volume that way. But when we have an irregular solid like this rod here, which looks like it might be a little bit misshapen on this end, we can use determination of volume by the difference when submerging it in a liquid. So what the scientists did is they took a graduated cylinder and they filled it with some liquid and probably some blue food coloring in here, and they determined that the volume of the liquid with no zinc in it was 35.5 milliliters. Then they added the zinc bar to it and they determined the volume to be 45.0. So the overall volume of the zinc, so if I put volume of my zinc, is just going to be equal to the total volume at the end, subtract the initial volume, like that. So I'll put my units. So I'm going to end up with what? 9.5 milliliters in this case. So then if I want to determine the density of the zinc in this case, I just use my same old formula. D is equal to M over V. I plug in my values, so 68.60 grams divided by 9.5 milliliters. I should only have two significant figures in my answer, and I get 7.2 grams per milliliter. There we go. All right, so let's move on from there. It says here, a little practice problem. It says, what is the density in grams per centimeter cubed of a sample of metal if the water level in a graduated cylinder rises from 25.0 milliliters to 33.0 milliliters? Well, the first thing is that it wants the density in grams per centimeter cubed. And a milliliter, 1 milliliter, is equal to 1 centimeter cubed. So we can just convert the 25.0 milliliters and the 33.0 milliliters into centimeter cubed right away. So I put my formula down. Density is equal to mass over volume. I have my mass, which is 48.0 grams. And then my volume is going to be my final volume. So this is my VF. And I'm going to subtract my initial volume, VI, from that. So I'll put here my total volume is going to be 33.0 milliliters, subtract 25.0 milliliters, like that. So 33.0 subtract 25, so it's going to be 48.0 grams divided by 8.0 milliliters, and my density is going to be equal to 6.0 grams per milliliter, like that. There we go. So that's a pretty reasonable practice problem, I would say. All right, here's another one. It says here, John took 2 teaspoons of cough syrup, okay? If the syrup had a density, so this is my density, I'll just put that here, D, of 1.20 grams per milliliter, and there is 5.0 milliliters in 1 teaspoon, what is the mass in grams of the cough syrup? Well, in this problem, I don't really need to be concerned about the teaspoons because it's giving me the density and it's giving me the volume of a teaspoon anyway. So this is going to be my volume. So, and if I write down my formula, D is equal to M over V, they're asking me to solve for mass. So I'm just going to say mass is going to be equal to density times volume, because if I multiply this side by volume and this side by volume, here my volumes are going to cancel out, so I get mass is going to be equal to density multiplied by volume. Then all I have to do is plug my numbers in, so I put 1.20 grams per milliliter multiplied by the volume, which is 5.0 milliliters, and I get that my mass is going to be equal to 6.0 grams. So there's a problem where you have to rearrange the formula. All right, in order to solve for mass. So specific gravity, so the last thing I want to mention is specific gravity, which is just the relationship between the density of a substance and the density of water. So all you have to do to determine specific gravity is just divide the density of a sample by the density of water, which is 1.00 at 4 degrees Celsius. And it's a unitless quantity because if I'm taking the density of my sample, which is in grams per milliliter, and I'm dividing it by the density of water, which is in grams per milliliter, the two values are going to cancel out like that. So there we go. So let's take a look at a question. So it says here, an unknown liquid has a density of 1.32 grams per milliliter. What is the volume of a 14.7 gram sample of this liquid? So here in this problem, I'm given density and I'm given I'm given mass, and it's saying what is the volume. So I have my formula, density is equal to mass over volume. So I need to solve that for V, and V is going to be equal to mass over density. Then I just plug in my numbers. I've given my mass, which is 14.7 grams, and I'm given my density, which is 1.32 grams per milliliter. Now, by my algebra here, you can see that grams and grams cancel out, and I have milliliters in the denominator of my denominator, so that makes it a numerator. So then I divide 14.7 by 1.32 in my calculator, and I get 11.1 milliliters as my volume. So now we've done an example where we've calculated density, and we've solved for mass in another problem, and we finally solved for volume. So the last question I want to cover says, an unknown liquid has a density of 1.32 grams per milliliter. What is its specific gravity? Well, if you go back a few seconds, you'd see the formula for specific gravity was equal to the density of my substance. So in this case, it's 1.32 grams per milliliter divided by the density of water at 4 degrees Celsius, which is 1.00 grams per milliliter. I hope you can see that the two units are going to cancel out completely. I take 1.32 and I divide it by 1, and I get that my specific gravity, I'll just write here SG, is equal to 1.32. So specific gravity has no units. I hope that's helpful in learning about density and specific gravity.